Yo, what's up? Let's get some shit done today. I'm gonna try. We're going with music, first of all. Background music once again, so please tell me if this music is too loud or too quiet. And what's up, Derek, and what's up, Fabic? Okay, so I'm gonna pull back on the experimentation today. I think we have arrived at something that we can use. We will probably have to go with 2 to the power of n plus 1 textures for the terrain, but I think I'm okay with that. So it's a not a what is it called, power of 2 texture, but we're still gonna force MIPS being generated. We just care that at the highest resolution we have a 1-to-1 relationship between vertices and pixels. And if we want to allow for quad tree or correct subdivision, and we want that relationship to be true, we need to have a data texture of 2 to the power of n plus 1. So we're gonna go with that one. So what I want to do now is I want to take our quad, I want to distort it based on or displace it based on a full resolution texture that we decide. Double check so all the normals get calculated the correct way and so on, and see how it behaves when we decrease the tessellation. And finally, I want to see how it works with, so we do a final split, we do tessellation, and then we have a geometry shader phase, which does a final split to get a smoother area. I want to refine that final split, but let's see. So I think we're gonna start by doing see here, what do we have here? I wonder if this, yeah, we're gonna start by regenerating all of these so that we get the same noise for all of them. And I don't think we're gonna go all the way down to 4x4, but we might end at 16x16 and 17x17. Although I wonder, yeah, so let's do this. Like that 2 to the power of n plus 1 doesn't really sit too well with me, but yes, we're just gonna have to accept it. Terrain height test 25. Okay, there we go. And then I want 512, so 513, I suppose. Two 556, so 257. Uh, 128, 127. Two 556. One 128, 129 is what we want, sorry. $29, right? With 64, 65. $33. And finally, we're gonna go with 17. Very nice. Okay, 125, 5. Is this correct? 1024, 512, 256, 128, 64, 32, 16. We're gonna start experimenting with, I want to test 129. Height map size. Yeah, let's see if we can get this correct now. Mesh dimension 1010. Yeah, what's up, Retina Studios? How's it going? What are you working on? It's going pretty good so far. Just started. We're working on proper tessellation. It has been a lot of experimentation, but I think we have arrived at a solution we're going to go with. And the tessellation is going to be used for ground, water, snow, whatever. And that's why it has been so important for us to, or for me especially, to understand it and to get a solid implementation in place. Let's see here. I'm gonna call this one resolution. Let's put it here. So if we have a resolution of 3, I'm gonna bring up the notepad again. If we started with the resolution of 3, we get 3, 5, 9, 17, 33, 65, 129, 257, 513, and not 5, which links up with this, so that's good. So let's start with 3 and see what we have. Nathaniel, oh nice, sounds cool. Just switched accounts. Yeah, it is pretty cool, but it has been it's been interesting, to say the least. So let's see here. At the subdivision amount of 1, we have the original mesh. So we have 1, 2, 3 vertices. So this is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We also want to do how to this one, I think. I don't even know if we have an original mesh of actually 0, 1, 2, 3, 4, 5, 6, 7, 9. If we have an original mesh of 3 vertices, I'm not entirely sure we can get up to 129. We have a maximum amount we can tessellate, but let's see. So 1, we have 5. 9, 17, 33, 65, 129. Yeah, and then we can't get any higher. So if we have a texture of, or rather, this is a number we need to remember. So we can go up to 7. Or could we go to 7? Or okay, 6 is our limit. We need to remember this number. So that means that we can, basically what we're doing here is we take 2 to the power of 6. Right. So we can subdivide of a maximum amount of, what the hell is it? 2, 4, 8, 16, 32, 64. We can subdivide a maximum number of 64 times. This is important because when we create our terrain later on, we're going to adjust it a tiny bit. So when we create our terrain, we specify the maximum number of subquads this terrain will consist of. And then we go back from there and to the minimum amount of quads we can visualize this terrain with, and that's the mesh we generate on the CPU and send down to the GPU. But so if we want to go up to 128, so if we want to go up to one sec. Okay, so we get to 128 here. So that's good, or 129. Right? Let's see. 3, 5. Let's do it like this. 5. One sec. Okay, back. So where were we? 3, 5, 9, 17, 33, 65, 129, and then we can't get any higher. Okay. So for instance, if we would like to get up to 1025, we would like to go 1, 2, 3 higher. So our initial mesh would need to be, let's see here. Let's see. It would need to be 17 times 17 vertices initially. I just want to double check if this is true. So let's go with 17 here and see what we have. Is the plan to catch a bunch of LODs at startup? The plan is to the plan is basically to be able to render a very high detail, high resolution mesh of a terrain or snow or water, but only if we're really close to the camera. So if we're far away, we are not going to do any tessellation on the GPU. If we're up close, we're going to do a lot of tessellation for the mesh. And right now I'm just trying to calculate like what should the, depending on how big the terrain is and how detailed we want it to be, what should be the initial parameters for the tessellation to fully work, pretty much. Yo, what's up, Geralt? Good morning, good morning. So right here we start with, when we build the mesh on the CPU, we start with a 17 times 17 vertices, right? So we're at this point. So this is our 0 pretty much. So we have 17 vertices, 33, 65, 129, 256, or 257 I mean, 513, and finally 1025. So look at this. And then the idea is to also add a final split on it, like this. But we're gonna get to the split eventually. But if we take a look at this one, so right now we have a mesh. What kind of performance do we have here? Main camera. Let's align this camera as well. to right about here. And then if we do the final split as well, so right now we're around 300. I don't think we'll really lose that much by doing the final split. We get a little bit less frames, a little bit less stable, but it's not that big of a effect. But also, if we take a look at this one right now, we currently have a mesh of 125 times 125 vertices, but the underlying texture we use only has 129 pixels. So there's really no idea to... I don't think... We're gonna double check this later on as well. Like, I'm wondering if we have a mesh that has a greater resolution than the underlying data texture, is there really anything to gain there? By just doing raw tessellation, I doubt it. If we add some Bezier manipulation, we might get a little bit of a smoother area. But yeah, Nathaniel, then that looks great. Yeah, we're getting there. So tessellate only when you need at runtime. Exactly. So we're gonna... Like, in this game, we already have a pretty good terrain solution. The problem has been, or it hasn't really been a problem up to now, but we have previously done tessellation, but not with any structure to it. So we have just tessellated however we want, pretty much. What we want to add now is structure to it, some constraints, so that we always tessellate in a quad tree fashion, i.e. one quad becomes 4 quads, 4 quads becomes 16 quads, or whatever it is. So, like, we want to tessellate in a uniform pattern, basically. We can see it here, i.e. this quad, in the next tessellation stage, this quad becomes 4 quads, and in the next tessellation squad, this quad becomes 4 squads, and so on and so on. And this has really not been fully possible with our previous solution, so we're just refining it a bit. Domin John, what up? Is this Minecraft? Eventually we're gonna have something like this, so no. But one might think. Nathaniel, yeah, cool, I've seen a few good demos of this working for planet generation. Yeah, this is... I don't think this is anything special. This is what you usually do. So if you work with height map based terrain, this is like the go-to thing you do, i.e. quad trees. If you work with voxel based terrain and you don't want to go the Minecraft route, you usually do it with an oct tree. What I think will make this a little bit more special in the end is how we solve the split in the end. But we're gonna get to that one. Good morning, Harukanan. Okay, so now we have figured out that the maximum amount we can tessellate is, what did I say, 2 to the power of 6. So 64 times. So i.e. if we start running our game and we eventually want a 1024 times 1024, or 1025 times 1025 mesh, we're gonna have to go back. We should be able to do... We should be able to calculate it like 1025 minus 1 divided by 64 plus 1. So if we call our, like the highest resolution is at X, so this is the resolution we want to render the terrain with at when we're closest to it. So this is the best resolution. Then the start resolution, or the resolution of the mesh we generate, should be equal to minus 1 divided by 64 plus 1. X start, X final. Right, so 1025 is the final. We do minus 1 divided by 64 plus 1, 17. We can also, this one, we're going to call this one y, and y is equal to 2 to the power of subdivision, I think, or actually division and subdivision is equal to 6. So I think this one is controlled by hardware, or the HLSL implementation of tessellation. We can't tessellate more times than 2 to the power of 6. So something like this is good to know. So in this case, if we have a 129 texture, so if we take the setup, our end texture is 129. So we do 129 minus 1 divided by 2 to the power of 6, which is 64, and then minus 1, but that is not entire, or plus 1 should be the final one, right? So okay, 129 minus 1 divided by 64 plus 1, 3. So we do resolution 3, we play. Nathaniel, how come it is 2 times subdivision plus 1? Yes, we found out that yesterday, and maybe I can show you real quick. So now we have a quad that is 3 times 3. At the final amount, it's 129 times 129, which links up with the texture. Great. As to the 2 to the power of n plus 1, that's something you usually do when you want to support quad tree and terrain. I can link you a thread here real quick. If I can find it. Here we can go. I'm just gonna link it in chat. There we go. That one goes into detail. The theory behind it. We pretty much found out, or I found out the hard way yesterday, why that's the case. Although I do like to experiment, so I don't see it as a loss. But yeah, we did some testing here. You could go or we floated the idea of going with a padded version. So I really want my terrain data to be a power of 2 texture, because I want the MIPS to be pixel perfect, basically. But if we want to achieve that, it's not really achievable unless you offset your vertices and work with some added textures. My VOD is up on my YouTube if you want to see the struggles yesterday, but we eventually came to the conclusion, like so many before us, that 2 to the power of n plus 1 is probably the way to go, even though you get some fucked up MIPS. Yeah, it's pretty much tied to the subdivision you eventually do. You're always gonna have an uneven amount of vertices when you subdivide. So think about it. No matter what we start with, we can start with 2 vertices. When we subdivide, we get 3 vertices. Then when we subdivide again, we get 5 vertices, and so on and so on. The number of vertices we get are always going to be equal to 2 to the power of n plus 1. So if we want this type of subdivision, and when I say this type of subdivision, I mean 1 quad turns to 4 quads, and on and on and on. Which means that if we also want to place a vertex in the center of a pixel in the underlying data, the texture itself needs to be 2 to the power of n plus 1. But okay. So now we have figured out this relationship. That's very good. So let's move on to... So right now, our vertices are not placed in the center of a pixel, but we have this implemented, I think. Let's see if it works. Include scale and offset. So first of all, we need to define our height map size. It's 129, 129, and then we do include scale and offset, and we get this, which is not entirely correct. So let's double check this one. I think I screwed this one up yesterday when we were experimenting. So it's down here. What we want to do is we want to offset it by half a pixel in each direction. Oops. Like this, and then we want to scale it by size minus 1 divided by this, I think. Let's double check. Something like that. It's not that visible over here. But here we can see that each vertex is now placed. Not really. It looks to be a little bit offsetted here. Yeah, okay, we have the scaling is not entirely correct. Okay, Chaiman. Don't you know how to realize lighting like in Valheim? I mean, every light ray actually lays on each texture picture with shifting intensity. I don't know exactly how lighting is handled in Valheim. I haven't played it. I've played it for like 1 hour, I think. If you have a Google some image exactly what you mean, preferably on Imgur, I could take a look. Okay, our scaling is wrong. I'm having a real hard time to actually get how we want to do this. We want height map size -1. Isn't this how we want to do it? Unless this one wants 128. Okay, this looks way better, right? Each... No, it does not. 129, 129. It's like having pixels in the center of verts. You should be able to make better use of the average normals from the four surrounding verts. It's just when we read the value, we will get like a pixel perfect value instead of bilinear interpolated value, pretty much. And that will, of course, make the normal calculations a bit more precise. Like, I hate this scaling so much. Never seem to get it correct. Let's do... So we scale by 1. So now we just offset by half a pixel. But that means that we lose... the fuck do we? Yeah, we lose. Oh, we might have been correct actually. So minus a half pixel, which means that we have some extra here. So we want to make the a little bit bigger, so we do, or smaller, so we do this. And what do we get? -1, I mean. Actually, -1, 129. Gauge, maybe it's like cell shading but with lower light probes. Oh, they have a really low poly style, I think. Right? If I remember correctly. -1.0. We get 128 divided by 129. We don't get the correct. We need to go. What am I missing here? We offset it by half a pixel. And then we want to make the UV bigger, right? So, or smaller. One should be equal to... Yes, one should be... We want to make it smaller, but I wonder if... Height map size... Isn't Valheim voxel based? Can we make this bigger? It's a low poly style with low resolution textures, making it look pixelated, I guess. Don't see any voxels here, I would say. Low poly models with low resolution textures, pretty much. Right. Okay, back to this shit. Yeah, we want to make it smaller, height map size. Nathaniel, I'm pretty sure it's a custom voxel engine. It's pretty neat. It might be behind the scenes. I don't know. But when you say voxel-based engine, let's see, what is it called? Thinking more of pare down. So when you say voxel based, I'm getting more this, right? So here everything is voxels, right? So you can see everything is built up of three-dimensional pixels. Everything. If we do Valheim and we take a look at the buildings here, it looks more like a regular mesh, right? And then you have, for the grass example, you have like low resolution texture, which makes them appear voxel-ish, but they don't really have any depth. We can take a look at the character as well. It's not voxel based, it's like old school. But then again, when it gets to the lighting in Valheim, I don't know how that's implemented. It might be very well be like some sort of voxel based stuff that I can't speak for. Cube World is voxel based, for example. Yeah, Cube World. Yes, exactly. So you get characters like this, right? But okay, what am I doing wrong here? 129. Offset it by half a pixel. Harukan and Cube World, the biggest letdown in voxel history. Very sad. I don't know. Two, although so basically what we want to do is, okay, if we have a texture, a 9x9 texture, or we can take the easy 8x8. We want to make the UV, instead of going from 0 to 1, we want the UV to go from 0.125, isn't it? Something like this. Harukan, the game itself is awesome in the end, but it was supposed to be so much more when it started. Developers cut so much promised features out, it was almost nothing left. Oh, that's sad. I don't know, I don't remember, like, I've heard about Cube World previously, but it was like... I always saw it like a higher resolution Minecraft, pretty much. I think they retired it. Like, it's always sad when you have a lot of promises and a lot gets cut. But let's see. Why, oh why? Height map size -1. Why doesn't this work? What am I missing? Or is it actually... No. But then again... Okay, do we have it here? I just forgot. No, we don't. Or fuck, yeah. I think I'm in the old mindset, aren't I? What we need to do here, we don't need to scale it at... Do we? 129, 120. Yeah, we need to scale it. Let's go with a little bit of a simpler one. 17 times 17. And what did we have initially? We have 3, so we want to subdivide it 3 times here. And we need to scale it by... Like this. This is the correct scaling, isn't it? So now we get all the pixels. I reckon we want to scale it a bit more actually. Should be minus here, shouldn't it? Oh, do we lose? Do we lose the information there? That's weird. Have I screwed up 5? No. Why can't I seem to get this one to work? I only have 16. We offset too much. 1 divided by height maps size Y. This is 17 times 17. 17. Okay. It might help to look at in this direction as well. Let's see. Yeah, we offset forward, that's minus. Yeah, we don't want to do plus here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I only see 16 pixels. Because we... so 0 becomes half a pixel. Right? Something is amiss here. 17 times... Oh, okay, this is the exact same issue or error I did yesterday. All of this is fixed by simply doing this. I'm pretty sure. Non-power of 2. $17. Thank you. And we do, yeah, plus. And then we do this scale as well. 1 sec. Okay, back. A little bit annoyed over this thing, but also glad we didn't waste too much time. Yeah, Nathaniel should have found this earlier, because yesterday I had the exact same issue. It was just the first thing we did this morning was to re-import these or regenerate them, and I forgot to unclick this. So pretty much when we import them, it's 17 times 17, it's a non-power of 2 texture. Unity remakes it into a power of 2 texture. Okay, that sucks. So all of our calculations was correct from the get-go. It was just that the texture was 16 times 16 instead of 17 times 17. Exactly. Okay, great. And this should be, if we do 129 times 129 and we go up to 6 here, it might be bit harder to see, but we should have the same here. So now every vertex is located in the center of a pixel, and we're good to go. Okay. What I'm thinking, yeah, annoying problem, but the release of stress did. Like for a minute I thought I was going insane. Like everything made sense in my head, but the result was off. One sec. At the beginning of this stream, I said we were done experimenting, but we're not really done. So, one thing I want my terrain to do is, it's like a final step, basically. And that can hopefully bring a little bit extra improvement to the silhouette of stuff and things like that. And what I'm talking about is, so we start with a quad, we subdivide into quads, and we get something like this. We don't have any control of how the quads tessellate to, or how they get split into triangles. But we add a final step that does this. And that's... So if let's see if I can find the correct one. Yeah, if this one is high, this one is high, this one is high, and this one is low, we get a jagged look on it after we displace it. If we add this one, so high, 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 low, we get more of a refined slope, or that's what I'm hoping for at least. But let's jump back to this one. So basically what we're doing is, so we have this, we either get this or this, unless we add the extra geometry step that gets us this. But what the geometry shader actually does is, let's take this one and put it here. The geometry shader, it doesn't know anything about adjacent stuff. It can only handle, since we have a tessellation before it, it can only handle point, line, or triangle input. We have gone with triangle input, so we get something like this into our geometry shader. What we do right now is that we then calculate an extra point here, and then we return a triangle strip of 2 triangles. What I'm wondering, or what I want to experiment with today, is basically a solution where we leave the last tessellation step to the geometry shader. So instead of just splitting it like this, let's add this one here as well, and we're gonna color it green maybe. I wonder if we want to do something like where we add, I guess we're gonna have to add it here, 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 and something like this, I think. need any more? I wonder, so I can see, I want to try and explain some of the positive things I see here. We're gonna get some duplicated calculations. So right here we calculate this point 2 times, because this other triangle doesn't know about the first triangle's calculation of it. But I want to make this make sense for myself before I fully commit to it. Nathaniel, this is all really interesting to watch you navigate. Yeah, I think it's very interesting stuff we're navigating. I appreciate it. Yeah, basically, this is what we're working with. So right now our solution only does this, but eventually we want it to do this. And basically what we get here is our solution would get this, our current solution would get this, if this was subdivided once more. Okay, so the most negative thing with doing this in the geometry shader is that we only work with triangles in the geometry shader. So this, and this point, all of these points, or not this one actually, but these 5 points are going to be calculated twice. But it's done in parallel on the GPU, so I don't think it matters that much. The positive thing, if we let the geometry shader stand for the splitting of quads into triangles and the last tessellation, is that we know exactly which vertices are new for this subdivision amount. So for this one, we know that this one, this one, this one, this one, this one, and this one, they are all new, i.e. they didn't exist in the previous tessellation amount. And that means that based on the distance to the camera, we can fade these. So when this one, for instance, when we pop it in, we interpolate its position between this one and this one. And then the closer we get, the more we calculate its end position. So that means that we don't need to do any of that in the tessellation stages or in the domain shader. We just do it in the geometry shader. And I think that's pretty neat. But before we do this, now when we have vertex and pixel aligned points here, I want to properly calculate the normals. We already have that in place. And I also want to properly calculate the new center point positions. Do we actually do that already? I don't know if... Yeah, can we get a good silhouette going here? Doesn't look too good, does it? Now if we take a look at this silhouette here, without the extra points we get this. It's a little bit more refined. I'm a little bit worried about this one though, but we'll take a look. So our extra points now, they end up between 4 pixels. We'll see. But let's start with the normals. This I also want to improve quite a lot. So this is the splitting of 2 triangles into 4 triangles. But here we calculate normals with high quality. So once again, let's take we have calculate normal from texture low quality. This one takes the left, right, and up, down neighbor and just does a cross product between them. The high quality also take the up, left, down, right, and up, right, and down, left. So we take 8 neighbors instead of 4. Then we also have the medium quality, which is connected neighbors. The problem with doing the tessellation is we don't really know which neighbors are the connected ones. So if we take a look at this one, here we have up, down, left, right, but we also have up, right, and down, left. But if we move over to this part, or actually this part, here we have up, down, left, right, and up, left, and down, right. One thing I noticed, however, if we go with the split, then we know that every point so this point has 8 connected neighbors. Up and then half up left, half up right. But if we take a look at these points, they only have the diagonal neighbors. So I'm wondering if we go with the split solution, we probably just want to base the normal of the up left, up right, and down right neighbors. And I want to see what kind of result we get with that. So first of all, we're going to start with if we jump to this one and we check when we calculate the normals, we send in the height map, bilinear clamp sampler, the level, which we want to put at 0, I think. This one we're gonna have to figure out as well. We send in the UV, the step UV, which should be equals to not this actually, but for now we're going to do 1 divided by height map size, and we work, so we do 1 divided by 129, so we know big each pixel is, and step world space we just do step UV times dimension X. We don't care about X and Y right now. We're gonna set this one at 0. And we have max height as well. Okay, normal from texture, high quality. And here we do return normal in world space. Looks pretty smooth. I wouldn't... I wonder... Although, one sec. Okay, it looks pretty good. Nathaniel, for the new words, won't need to read from the height map past a certain point and can just interpolate via normals between the neighbors. Yeah, what I'm afraid of is... so we get a new point here. Right. So if we take a look at 1, we get a new point here. If we just interpolate this one's normals from neighbors, this then we only know about this point and this point and this point, because we're adding this point in the geometry shader and we only have access to the triangle points. So that would mean that when we add this point for this triangle, we base the normal of this, this, and this. But when we add the point for this triangle, we base the normal on this, this, and this, which means that we generate the same point, but the same point has 2 different normals depending on which triangle we interpolate it from. Right. So we're gonna have to calculate it for this one, as if it was new, I think. But like if we were to tessellate this mesh one more step, i.e. making the mesh higher resolution than the underlying data, then we could just rely on interpolation of the normals, because we don't have that specific data. I hope that answers your question. But okay, what I hate about this, I think, let's see here. The generated normals, they look extremely beautiful here. So we have a nice gradient with no lines or edges. What I'm worried about, however, is if we return color instead. So if we return the color instead, and color is something we calculate with a blin fong, we send in position in world space, position in clip space, normal in world space, view direction in world space. Both this one and this one are interpolated from the geometry shader to the fragment shader. If we return this color instead, we get these artifacts. And I have no idea why. After having seen... I wonder if it's something wrong with what we send in to the... Because if we take a look at this pattern we see here, and we return normals, We don't really see that pattern here, do we? So... why is this one apparent here? Um, hmm. Yeah, we have it on the... we have it here as well. Seems to be something with the... ooh. I'm pretty sure... or if it has to do with the geometry shader we add. I want to double check this. Let's do... let's just do this, I think. Geometry. And now we don't have any geometry shader, but we still get it. Nathaniel, is it banding? It's some sort of banding. Like, I think... we don't get proper value interpolation on the triangles. Is that it? I wonder. Position. You... one sec. Position clip space. We offset this one. Everything seems to be correct here. And if we do low quality normals, we have the issue still. But as I said, I find it very weird that we don't see it for the normal, which makes me think... I mean, it could be just a color scheme here. Input.normal vs, let's just take the X or the Y or the Z. On Z we get it. Really do want to get to the bottom of this before we move on. So what do we do with the normal in world space? Calculate normal from texture low quality. But this one, once again, normal, the Z one is a little bit off, isn't it? Step world space, step UV. Max height. Way more apparent when we go here. Okay, I wonder if we currently don't care about... We don't recreate the tangent or binormal here. I wonder if that might fuck things up. I don't think so. Calculate normal from texture low quality. What I'm wondering is height in world space times whatever we sample. Level here we send in 0, don't we? Level, yeah, we do. T height. Normalize. I wonder... It should be okay. So basically what we're doing is we have a point, we have a neighbor, we have a neighbor, we have a neighbor, we have a neighbor, and then we recreate these points by offsetting them, and then we read their height. So we recreate these 4 points and their height, and then we create a vector like this and a vector like this, and then we just cross product, or we do the cross between those two to get a vector perpendicular to is perpendicular to, yeah, and that's our normal. I don't see any apparent wrongs here. I mean, it could be height. Yo, what's up, John Olson? Yeah, we're back with music. Thanks to Chillhop. Johnson, didn't you say to move on to other things than the snow? Depends on how you define other things. We're finalizing, hopefully, the tessellation, and it's going to be used for multiple things, but including snow. I don't see... Or actually, one sec. No, I don't see anything wrong with these calculations right here. Unless... Do we get any difference if we do coin sampler? No. Oh, good morning, PG King. Yeah, the interpolation over the triangle looks wrong here. Like this color or this whatever normal we get here is the same as this one and this one, but then we get a lighter line in the middle. It's weird as fuck. It's extremely weird. It has to have some sort of common name in the shader community. Maybe. It's extremely weird. If we take a look at the quad here, each of the vertex making up the quad have roughly the same shading, but then you get different shading in the middle of it. It's something wrong with the interpolation between the fragment shader, I would guess. We don't use the geometry shader right now, so it's not something with the geometry shader. Fragment shader input. Color. We don't use this one. Just have to double check one thing. Util lighting. Normal VS. Position clip space. But it is, once again, it is visible if we do yeah. I don't even know how it's possible. Could it be Mm. UV, step UV, step world space, height world space. Yo, what's up, Spires? Thank you for the raid. Appreciate it. You too, you too. It's weird. We're calculating normals here from a on a displaced mesh, and we get this little bit of an artifact which I can't seem to explain. I want to summarize it as, or it looks exactly like something is wrong with the interpolation of the triangle values over the triangle, but I can't explain why that would be the case. When we calculate the fragment color of this triangle right here, when we get it to the fragment shader, we have a fragment normal is calculated by interpolating this point, and this point. That does not seem to be the case. Like, if this one gets shaded dark, this one gets shaded dark, and this one gets shaded dark, why? How is it even possible that the center... I don't get this at all. Like, if we take a look at, let's output the normal Z again. Did I remove it? Yes, I did. Return input dot normal vs Z. How the fuck does this darker area in the center here make sense? Okay. Okay, I get it. This point is... have a 0 value in the Z. Get the spread down here, okay. I wonder. One sec, I want to double check the backface culling here. I wonder... It doesn't look right. That's for sure. Let's see here. Is out of bounds. Is out of frustum. Should backface cull. We send in 4. No, I just thought I'm seeing these artifacts here that we're not culling it properly, but that has probably nothing to do with this. I just got side. Sidetracked. This ain't right, 100%. Something is amiss. Nathaniel, it's hard to even describe. I've been trying to find some forums on this artifact. Yeah, I was just about to do that because honestly, I have no idea. So if I try to analyze this quad right here, and we take a look at the shading on all of the 4 points, there's really nothing. Like, we shouldn't be getting a center that is brighter than any of these 4 points, I would have guessed, but I mean, we could. I want to see what happens if we do. What if we do? Step UV, step VS. Just gonna double check if 3D object cube 0. We want to do position. This is a 1. We have the correct size. Because this is a unit cube, right? So it's 10 times 10. Oh, maybe. No, we do float, step. Float as well. We take the red value. Unless... No. But I want to try, what happens if we do 0.5 times 0.5 times, so we just walk. Gets worse. Do you feel like the center of the face's interpolated value is more correct than the verts themselves? Seems maybe too bright to be right. No, I think the verts have the correct values, but it's interpolated wrong in the center. I think. Oh. So many things that can go wrong here as well. Transform world to age clip. Honestly, it could also be... Look at this one, for instance. What the fuck? A viral error. Yeah, that looks extremely weird. Hence, when outputting the normals, they look smooth, right? Just a norm, all of the normals looks pretty good. Or at least it's harder to see that pattern. But if we just return the Z of the normals, then it's very visible again. Okay, I want to test the interpolation to this fragment. I wonder if we do... let's see, color. We don't do anything here. Quad domain. We have disabled the geometry shader. Yes, we have. I want to try and do domain. Oh, fuck it. Let's do return float for UV input.uv.x, input.uv.y, 0 and 1. Looks beautiful, interpolates beautifully. mean, really? Really? Yeah, the set on the normal seemed to be pretty harsh, yes. This one... What the fuck? Something wrong. We interpolate... One sec. Back. Nathaniel, can I post a link here to post? I think might be useful. I don't know if it will be automatically removed, but you can try. You can try and see what happens. Because I take all the help I can get, because this problem I have no idea what causes it. UV interpolated. They're saying to store a higher... I mean, this one is pretty low resolution. 128 times 128. We can go to... We can't go any higher with... Like, if we double check the result... If we do quad resolution 3, instead we do... Higher resolution is always going to give better results, right? But I wouldn't expect this result on this low resolution. But if we go... so it's 17. We create a quad with 17 vertices. And then we can do... remove the selection wire. So now at the maximum tessellation like this, we have 1025 times 1025 vertices. And then we swap with a higher resolution height map, then we get something like this, which honestly looks kinda shit as well. Yeah, because we don't do we have 1025, 1025. And then something else we need to change. Have I hard-coded anything here? Height map size, dimension. Yeah, we get this result because we can only store, or the texture is RGB A32, so we can't really show. We can only show 255 different height values, but if we do, yes, we get this kind of. But I mean, we could do do we have like, honestly, if we didn't have this data truncation issue here, we would have, I think we would have a pretty smooth and nice surface. Yeah, I'm pretty sure. But we don't have to go this high. We can go 17. If we just do, let's do 513, so we go 9. We go 9. So then we get to 513, 513. I thought. Resolution of 9. 6 258. We should be at 513. Is there any information we can get from this? Why are we... Yeah, it's probably the same issue. So if we go 9, 7, right? No, 5. 5, and we play. We take quad, and we do 257, 257, 257. But we can see here that we have the same issues. Let's see. Nathaniel, bilinear interpolation in what is used to compute frag normal in the fragment shader from frag normal in blah, 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 blah. Yes. Interpolation is effectively linear at triangle edges. Exactly. That's why I'm wondering, like when we interpolate this fragment, we do it from with this point and this point. This one doesn't really affect it. So that's why we get these lines. But why the fuck is it darker here? Like if we take a look at this one, this point is dark, this point is dark, but we get a lighter interpolation in the middle. It makes no sense. I don't see the link in the chat, however, but num0, I will search for it after the stream. This is weird. Test quad, we're gonna auto-generate the texture as well eventually. Because right now we're getting limited by the number of values we can store in the texture, basically. But let's see here. Quad, we go to 3 again, and we use the 129. Like, even if we have a very low resolution height map, so we have a 129, 129, like this. We should not be seeing these artifacts. So if we take this triangle here, when we send it down from the domain shader to the fragment shader, we have a fragment located maybe here. This one, to get the world position and normal of this fragment, it does, or for any fragment in this triangle, we do barycentric coordinate or barycentric interpolation between these two. But if we're located on this edge, this point doesn't really affect the end result, so we pretty much just get a linear interpolation between this point and this point. What I'm questioning is, this point looks dark, and this point looks dark, at least relative to the center here. So if the normal we get here on this line is interpolated between this point and this point, why does it appear to be lighter? Like, what is... It makes more sense if we just output the not the color, but the normal instead. But then we find another good example. Where do we have this one? This square right here. I don't know how visible it is during the stream or through the stream, but we can take this quad, this one right here. Why does the Z value on this point and here appear lighter than the one we get in the center? It doesn't make any sense if this were linear interpolated. So what I'm trying to say is, if we have a value of 0.5 here, or if we have a value of 0.3 here and 0.4 here, we should only be able to get a value between those two for fragments here. But for some reason, it appears as if we get an even darker here. It's fucked. It's totally insane. Texture type. Default. Texture shape 2D, not sRGB. Don't care about alpha. Non-power of 2. if we don't generate MIPS, we don't get a difference. European G Swizzle wrap mode. I don't know, like, I don't know if it's... Here I think we have the best example. So to double check one thing, we don't do this at all. Nathaniel, no problem at all. Like, all of this information can hopefully lead us closer to this. What I suggest is adding an additional point of splitting a quad into... Oh, yeah. No, that's exactly what we're doing. That's what we're eventually gonna do. It's eventually gonna look... We're eventually gonna split it into 4 triangles. By adding a point in the middle. We have the code for it as well. But, like... we shouldn't be seeing this pattern here at all. So before moving on to the, like, refining this one, I want to get this working first, you know. Like, if we add our geometry back and we do this, that's eventually what we're gonna do, right? We're gonna add a middle point here, but this is mostly gonna be, it's gonna refine the normals as well and the shading, but it's mostly for our silhouette. But this is not what we're gonna do right now. I want to make this work without the extra point first. Like, something is definitely wrong here. Another alternative is to compute the normal directly in the fragment shader. Yeah, that was what I briefly tried. Here we can see it, but we still get the same artifact if we calculate the normal in the fragment shader. So it doesn't seem to be related to that. Like, I'm pretty sure I'm doing something wrong here. Or the cause of our error is, not here, but here. But. Or if I would guess, it's this one, but we can even do this, I think. Let's do this. Return dot product between input dot normal vs and 0, 1, 0. And I want to return. Let's do test. Test. Then we do return this one if it's bigger than test. Okay, let's see. Let's find a point. Here it's pretty apparent. This one right here, and then we do get this one back, quad 6, 7, or 7, 5. This one looks extremely good. This is what we want to see. This is exactly what we want to see. Like, this looks good. If we take this one is bigger than test. Still looks as I would expect. I'm pretty sure the interpolation works. Huh. Once again, this looks beautiful. On this side it looks good. Nathaniel, I love this stuff, although it's frustrating as fuck. It's so cool. Yeah, it's extremely frustrating, but yeah, I love it as well. I love it as well. But this checker pattern doesn't make any sense to me. None whatsoever. Normal V, is it view direction? View direction world space. Ooh, I think I know. I think I know. Should have arrived at this way sooner. I'm pretty sure. I hope. Fucking hell. We're gonna start by just a normal. Fuck. Maybe. Wonder if we want to do a safe normal. We haven't tried this one, right? I had so high hopes. I had so high hopes for this. One sec though, let's maybe. Okay, I have another thing that I have high hopes for. Let's see, but I don't, yeah, possibly. And it's the fact that up until now we haven't cared about Tangent v... one sec, I want to double check. Rain. Rain procedural grass. Text cord, really? Oh. Ooh. Main shader output. Which is our fragment shader input this time around. No. Okay, that is if we have a geometry shader, which we don't. I'm wondering if we need to include these. But we don't use them, so I don't think how they... I don't know how they could affect it. Could also be... It can be so many things. We don't really use tangent nor the binormal. I don't think that's the issue. We do normalize these two this time around down here. We could possibly, okay, now we're, when we calculate a normal from a texture, we can, from a height texture, we could do it in such a way that we get the normal in tangent space, and then we transform it to world space. But I don't see how that could be the cause for it. We normalized normal in here, I'm pretty sure. Do we want to normalize it here? Shouldn't matter. Returning that normalized normal. We can do return normal normal. Looks pretty damn good. The set, however, is fucked. The X and Y seems to be... The X is actually sort of fucked as well. The Y, however, seems to be... Okay. So, one sec. This is interesting, which makes me think, I'm wondering if step world space is the culprit. We do step UV is 1 divided by 129 times 10. Okay, let's do one sec. Okay, let's do like this. Fragment shader input, main shader output. Main shader output, we enable the geometry again. We do struct geometry shader output. Here we want this and this and this and this. I'm gonna skip and then we change to main shader output. We do position world space, normal, view direct. Skip this one. Do it like this. Fragment, here we do geometry shader output input. We have UV, we have normal, we don't have color. Position world space, position clip space. Okay, and then we remove this one right here. We do it like that. Here we do geometry shader output 1 is equal to and let's see here, output 1 dot position. Do we care about position in world space? Position world space, position clip space. Let's do it like this then. We had UV as well. That's about it, right? 4 things we send onwards. 1, 2, 3, this one as well. Yeah. Okay, like this. Now we do this. 0. And then of course we want to do this 3 times. Let's see. Okay, let's try this. Do we still have color here? Actually, we can do it like this time around. Output stream append. Why can't we append? Domain shader out. Geometry shader output. We still have this. Like, I think this is a perfect example where I don't... Like, this point definitely looks darker than this, doesn't it? But I mean, it can also be... It can also be a visual. I don't even know what it's called. Yeah, I'm pretty much at an end here. I have no idea. I have no idea how to proceed from here. Unless... we do float 3 for tangent here. Geometry we don't output. If you tessellate to that extra triangle, does it get rid of the artifact? We're probably gonna try that eventually. I don't know if I will have the time today. Like, the bottom line is... we shouldn't be seeing this. With or without that additional point. We're gonna do... let's do... vertex shader output. We do domain shader output, float 3, tangent, yes, texture 3, float 3, binormal, text chord 4, and we do 5 here. Now we do tangent vs normal. Okay, let's normal vs is equal to this. Util normals calculate tangent from texture low quality. Why not? Calculate binormal from texture low quality. quality. Text sampler level, UV, step UV, step VS, height VS, and then we just do. Probably want to calculate all of this in one method eventually, because otherwise we're gonna sample the texture more times than we need to. But okay, if we sample the tangent, let's go to the right. So we sample right and center is 0, no UV offset, and 0. And then we want to do, it doesn't really matter how we do it, but normalize center minus right. As for the binormal, we sample center and down. So 0, 0, and makes me wonder if we actually want to do which, if we base the normal on this, we should probably base the tangents on those two as well. So binormal, then we do up and down, and we just do normalize up minus down. And for the tangent we do right left, like this. Output tangent VS is equal to now we send it down to here, and we want to do just to see what we get. Okay. Oh yeah. Interesting result though. Oh yeah, we call it binormal. Okay, but now we don't return normal set or return color. And let's see how tangent oh yeah, we need to do it like Yeah. But that result looked like something we could use. Tangent has the same artifact. Binormal has the same artifact. Okay, nothing has changed. Okay. Okay, what the hell are we doing here? This is insane. Absolutely fucking insane. Yeah, we're just gonna go through every single bit we think it can be the cause of this, and hopefully check them off. Oh, this is insane. One sec. Could it be? Could it be? Of course it is. Oh, it has to be this. It absolutely has to be. I'm gonna be relieved. We're gonna check this, but I'm also gonna feel a bit stupid. So I want to try with just this one first. Holy fuck. Do we have it UV interpolated? possibly. Hope so. And then I also want to do... The thing is that we need to... Okay, let me try and explain. We need to keep the relationship between pixel and vertex, right? We want to make sure that every vertex is at the center of a pixel. And to do that, we need to offset the UVs and scale the UVs. And this is not something we have done before we calculate the normals previously. I missed it and it has cost me at least 2 hours. So I think this is the problem. But I wonder, so UV interpolated, so down to this point we have a full mesh with UV going from 0 to 1. We then UV interpolate. We just calculate the UV coordinates for this point given the interpolation we have done. And then we take that UV and we offset it and we scale it. So UV interpolated is now at the center of a pixel, right? Do we need to scale step UV as well? If we scale, I think so. I hope so. If we offset the... I wonder if we need to do this, basically. No, we actually did this without the scale and offset previously, and now we're trying to do it with the scale and offset. But I still don't get... the correct result. Height size 129, 10, 10. Come on. So now we have changed this one and this one. And this one. Let's do this. UV interpolated. I just want to see what happens if we return this one, but we do input.uv interpolated. No, yeah, UV, I mean. Input UV, we don't scale it or offset it down here. And we get this beautiful... Ah, yeah, we do. Yeah, we do. It's beautifully aligned. Was pretty sure this was the cause of it. So here we calculate the correct UVs here. We set it to UV interpolated, and we use UV interpolated here. Step world space, step UV. 1 divided by height map size. I don't think we need to scale it here actually. Or do we? Daniel, my brain is fried just watching you do this. Yeah, my brain is pretty fried as well. Fuck, I really thought we had it with this one. I find it extremely weird that we don't get any difference whatsoever, this one. Although I am pretty sure we want to do this eventually, right? One sec. Matter. Why don't we get 0? Okay. No idea. Step UV is just a float, so I don't think we can't normalize that one. Or that would just be to set it to 1, I suppose. It should be how wide is a pixel in UV coordinates, so between 0 and 1. Oh yeah. So when we outputted the tangents, we had an error. It's basically what we're trying to. Can I visualize? Like the normal together with tangent and bitangent should create a space pretty much. So the plane created by two of the, like, the normal should be perpendicular to the plane created by the binormal and tangent, and yeah, so on and so on. The only reason I added them was because I was wondering if if the interpolation got screwed up without them, but that was a long shot. Because, like, yeah, we've been staring us blind on this issue right now, but, like, it looks like an interpolation error. Only visible on the dark sides. Like, I don't get at all how. Why we get this checkered pattern. I'm probably gonna have to sleep on it. Yeah, it's like the center of the quad is brighter than the verts themselves. It makes no sense whatsoever. It has to be. When we go from the domain, so here we are still working with quads, but between the domain and the geometry shader, we split two triangles. Is something happening between those two steps that could fuck this up? It might be, it might be. Oh. I wonder. triangle. But then again, we had this problem without the geometry shader as well, right? Yeah, the result was the same via the fragment. Screwed up something with the... And we don't get position clip space here. Fuck it. Like, I could imagine we have some weird triangle flips going on here. It could possibly cause this. I don't know. It reminds me a bit of hard edges in 3D modeling software. Definitely does, definitely does. What I'm meaning by flipped in this context is that like the triangles making up this quad, these quads have been rotated, maybe is a better word for it. So when we interpolate, so the normal we have here should be located here actually. Maybe this normal is here, this one is here, this one is here. But honestly, I don't know. Yeah, probably gonna have to do some research on this, but I don't even know where to begin. I had... Okay, so two things I really thought was the issue, and it was not doing the normalization down here, and the second one was not scaling the UVs here. I am extremely surprised that this didn't fix the issue, because without this we have basically been reading the height values for the normals the wrong way. We've been reading them the wrong way for the height as well, so the height offset. So this one doesn't make any sense for me. Why this one didn't fix it. And I also wonder how stupid I'm gonna feel when we finally solve this issue. That I didn't catch it earlier. Yeah, you know what? I'm pretty fried. And I have to run. Yeah, this one is gonna annoy me for the rest of the day until tomorrow when we finally fix it. Because I have no doubt in my mind that we're gonna find the cause of it eventually. But yeah, unfortunately I gotta run. I'm gonna try and fix this tomorrow. Nathaniel, it's been enjoyable to have you here as well. Appreciate it. Appreciate you all. But my brain is so fried I can't even talk anymore. But yeah, I'm gonna give this a try tomorrow as well. Hopefully I can arrive a little bit prepared as well. Yeah, so have a great rest of the day, and hopefully I will see you tomorrow. Peace.